Now we'll look at the same problem, but now we'll try to do the mesh analysis. It is the same problem as before, but the modality is different. So we'll be going ahead with mesh analysis. So what happens in nodal analysis is we try to identify the node voltages. So we come up with equations that involve voltages. Whereas in mesh analysis, we come up with equations that involve currents. Okay, so first let me label currents here. Okay, so let me call this I1 and let me call this I2. Okay, right. Since the direction of I has already been given, and we know that current flows from higher potential to lower potential, so I can label the voltages on these resistors from the directions as this. Okay, yeah. Now I'll use a KVL in this loop. Okay, so I'll start at V1. Okay, I'll collect all the voltages. I end at the same point. Okay, so the current through this branch is I. So the voltage across this one is V is equal to I into R. I happens to be I and R is 5. So this is 5I, and I go clockwise direction. Okay, I encounter this branch, so the voltage across this branch would be I into R, that is 2 into I2. So this is 5I plus 2I2. I have to finish the loop, so I encounter the negative polarity on this, so this becomes minus 1 into I1. So all the potentials across a loop have to be equal to 0. Okay, so this forms one equation. So when you are trying to use KVL, that is you are trying to solve for currents, and there are current sources in the problem, like this one, like this is a current source, this is an independent current source. So in such cases we would also look at the nodes and write KCL and get current equations. Okay, suppose look at this node V1, we can write a small KCL here. Okay, the entering currents here are 5 amps, which is equal to the leaving currents, that is nothing but I1 and I. So this is also an equation in currents. In the previous problem we have taken the same equation and we have proceeded with the nodal voltages, but now we will keep it as it is. Okay, from this we will try and eliminate I1. Okay, so what is I1 from the above equation is I1 turns out to be I1 is equal to 5 minus I1. I'll submit the same in this equation. So what do I get? So this is 5I plus 2I2 minus 5 minus I is equal to 0. So on simplifying, what do I have? 6I plus 2I2 is equal to 5. Okay, yeah. Now I'll over here also I have a current source. I'll go with a simple KCL involving currents over here. So the currents entering that V2 node are I, and the currents leaving us 4 amps and I2. Okay, so this is also an equation in I and I2, whereas this is also an equation in I and I2. I solve for these two, and I'll get the values for I and I2. So I rearrange this. I'll get I minus I2 is equal to 4. Okay, so if I multiply this by 6 on both sides, what I have is 6I minus 6I2 is equal to 24. So I'll put this here, 6I minus 6I2 is equal to 24. Okay, so now I'll subtract these two. So this one is gone, so 6 plus 2 is 8I2 is equal to minus 19, or rather I2 is equal to minus 19 by 8. also know that I is equal to 4 plus I2. Remember, the objective of this problem is to find out I. So this I is equal to 4. This I is equal to 4 minus 19 by 8. So that would give me 32 minus 19 would be 13. 13 by 8, which happens to be 1.625 amps. So whatever may be the modality, we obtain the same answer. In the previous problem as well, we have done the nodal analysis and we obtained the branch current, that is the current flowing through the 5 ohms I as 1.625 amperes. Similarly, now we have done the mesh analysis and we arrive at the same answer.